guys, welcome to our new video. In this video, we will be covering the part 3 section of exercise 1.1 arithmetic progression. If you haven't watched part 1 and part 2, please go and watch it in our channel. So now moving ahead to the fourth question. Which of the following are in arithmetic progressions? If they form an arithmetic progression, find the common difference D and write 3 more terms. So here the basic idea is we have to check whether the given list of numbers form an AP. For that, let's take the first sub question, that is 2, 4, 8 and 16. So a very easy method to find whether it forms an AP or not, we will check the common difference. We know that the common difference remains fixed or unchanged. So let us check the common difference now. Here the first term given is 2, so A is equal to 2, and now let's find our D, that is common difference. 4 minus 2 is 2, 8 minus 4 is 4, and 16 minus 8 comes up to 8. So here it is not an arithmetic progression because D is changing, hence they do not form an AP. Now let's take the second sub question. 2, 5 upon 2, 3 and 7 upon 2. Here our first term is 2. So A is equal to 2. D is nothing but 5 by 2 minus 2, which is 1 upon 2. 3 minus 5 by 2, which is again 1 upon 2. 7 by 2 minus 3, which is again 1 upon 2. And hence, this list of numbers form an AP. Now, let us find out the other 3 terms. For that, we can use the formula A5 is equal to A plus 4D. That is nothing but 2 plus 4 into 1 upon 2, which is 4, and A6 is equal to 1 A plus 5D, which is 9 upon 2. And hence, we can find it in an easy manner. Now let's find the 7th term, which is A plus 6D, that comes up to 5. So the next 3 terms of the AP are 4, 9 upon 2 and 5. Now moving on to our third sub question. Minus 1.2, minus 3.2, minus 5.2 and minus 7.2. Friends, notice here that the given numbers are decimals and are given in negative. So always be careful in doing the calculations. The first term here A is minus 1 upon 1.2 and the common difference here is minus 3.2 minus of minus 1.2. Notice that minus into minus is plus and minus 3.2 plus 1.2 is minus 2. Now D here is minus 5.2 minus of minus 3.2, which is again minus 2. There is no difference in the common difference, and hence we can say that our given series of numbers is in an arithmetic progression. They have asked for the next 3 terms, which is really very easy. You can find A5, which is A plus 4D. Substitute the values of A and D, which comes to minus 9.2. Similarly, A6 here is A plus 5D, which is around minus 11.2. And A7 here is A plus 6D, which is minus 13.2. So the next 3 terms of our arithmetic progression are minus 9.2, minus 11.2 and minus 13.2. Now moving to the fourth question, that is minus 10, minus 6, minus 2 and plus 2. So here the first term is minus 10. Now let's find our common difference, which is minus 6 minus of minus 10, which is 4. Minus 2 minus of minus 6, which is again 4. 2 minus of minus 2, which is 4. So there is no difference in D. The common difference remains the same, and hence it proves that the given series of number is in an arithmetic progression. Now the next 3 terms which we have to find out, that is A5, A plus 4D. Substitute A as well as the D and it comes up to 6. A6 is A plus 5D, which is 10. A7 is A plus 6D, which is 14. So the next 3 terms of our AP are 6, 10 and 14. Now the fifth one, 3 plus root 2, 3 plus 2 root 2 and 3 plus 3 root 2. So 3 plus 3 root 2. So this is somewhat complex numbers plus whole numbers. So we have to be careful while going for addition and subtraction. Here the first term given is 3. Now let's find the common difference d, which is 3 plus root 2 minus 3, that is root 2. Here it is 3 plus 2 root 2 minus 3 plus root 2, which is again root 2. This shows us that the given series of number form an AP. So now let us find out the next three terms. A5, that is a plus 4d, which comes up to 3 plus 4 root 2. A6 is a plus 5d, 3 plus 5 root 2. And A7 is the a plus 6d, which is 3 plus 6 root 2. Now the sixth sub-question, which is 0.2, 0.22, 0.222 and 0.2222. Now let's find the common difference, which is 0.22 minus 0.2, which is 0.02. The second common difference, that is 0.222 minus 0.22, which is 0.002. And here it is 0.2222 minus 0.222, which is again 0.0002. This sum is quite confusing, but with careful calculations we can find that the d doesn't remain the same. It is not fixed. So hence this series is not an example for an arithmetic progression. Now moving on to the seventh sub question, which is 0, minus 4, minus 8 and minus 12. The given first term here is 0. Now let us find d, which is minus 4 minus of 0, which is again minus 4, minus 8 minus of minus 4, which is minus 4 again. So d is same, hence we conclude that this forms an arithmetic progression. Moving on to the next three terms, which are a5, that is a plus 4d, which comes up to minus 16, a6, that is a plus 5d, minus 20, a7, a plus 6d, which is minus 24. So the terms of an AP are 0, minus 4, minus 8, minus 16, minus 12, minus 16, minus 20 and minus 20. Now let's move on to our eighth question, which is minus 1 upon 2, minus 1 upon 2, minus 1 upon 2 and minus 1 upon 2. So here the terms are the same. So now let's find the common difference. The given a is minus 1 upon 2. D here is minus 1 by 2, minus of minus 1 by 2, that is 0. Here again d is minus 1 by 2, minus of minus 1 by 2, which is again 0. So here the common difference d is 0. In a AP where the d is 0, all the terms of the AP are remaining the same. So here we need not find the next terms, because it is very clear that the next three terms would be minus 1 upon 2, minus 1 upon 2 and minus 1 upon 2. Now the ninth sub question, that is 1, 3, 9 and 27. The given first term here is 1. Now let's find our d. 3 minus 1 is 2, 9 minus 3 is 6 and 27 minus 9 would be around 18. So this is not an arithmetic progression. So we need not find the remaining terms. Moving on to the 10th sub question, that is a, 2a, 3a and 4a. Given a is here a again. To find d, we will subtract 2a minus a, which is a, 3a minus 2a, which is again a. So this shows that this forms an AP. Now let's find the next three terms, which are a5, a6 and a7. a5 is equal to a plus 4d, which is 5a. a6 is equal to a plus 5d, 6a. And a7 is equal to a plus 6d, which is 7a. Now moving on to the 11th sub question, that is a square, a cube and a raised to 4. To find d, we will subtract a square minus a, which is not possible, right? And again here it is a3 minus a square. So this comes up to a into a minus 1, and here it is a square into a minus 1. So the d, it is differing and hence they do not form an AP. Now let's find the 12th sub question answer. Here the given series is root 2, root 8, root 18 and root 34. So this we will convert it into root 2, 2 root 2, 3 root 2 and 4 root 2. By doing this, it will help us in calculations. So now let's find the common difference, which is 2 root 2 minus root 2, that is root 2, 3 root 2 minus 2 root 2, again root 2, and 4 root 2 minus 3 root 2, which is again root 2. This shows that the given series is in a form of arithmetic progression. Now let us find the next three terms. A5 is a plus 4d, which is equal to 5 root 2, that comes up to root 50. A6 is a plus 5d, which comes up to 6 root 2, which is root 72. And A7 is a plus 6d, which comes up to 7 root 2, that is nothing but root 98. Now the 13th sub question, that is root 3, root 6, root 9 and root 12. For better understanding, we'll get it converted into root 3, root 6, 3 and 2 root 3. Now the common difference would be root 6 minus root 3. The subtraction is not possible here. 3 minus root 6 and 2 root 3 minus 3. So we cannot subtract this, and they are differing also. Hence this does not form an arithmetic progression. Now moving on to the 14th sub question, that is a square, 3 square, 5 square and 7 square, which is here the a is 1 and we will get it converted as 1, 9, 25 and 49 for better understanding and calculations. D here is 9 minus 1, 8 and 25 minus 9 is around 16. So here again the D is differing and this does not form an arithmetic progression. So we need not calculate the further three terms and all. Now let's move on to the 15th sub question, that is 1 square, 5 square, 7 square and 7 cube, which is D is equal to 5 square 25 minus 1, 24. And here D is equal to 49 minus 25, which is again 24. D is here again 73 minus 49, which is again 24. So here the D remains the same. So now since we have already proved that it forms an AP, we will now find the next three terms, which is A5 is equal to a plus 4d, 97. A6 is equal to a plus 5d, 121, which can also be written as 11 square, and A7 is equal to a plus 68, which is 145. So with this we are completing exercise 1.1. If you liked our video, please like, share, comment and subscribe to our channel. We will come with new videos and new concepts in our upcoming videos. Thank you for watching.